Hello, welcome to today's video. We'll be looking at LeetCode problem number 1604, alert using same keycard 3 or more times in a 1-hour period. In this problem, we are told that each time a worker uses their keycard, a security system saves their name and the time it was used, and the system will emit an alert if any worker uses their card 3 or more times in a 1-hour period. We're given a list of names and a list of times where each index corresponds to a name and when they accessed the building. And we want to know how many workers accessed the building 3 or more times within a 1-hour period. We're also told that the times are given in a 24-hour time format, with the hours coming first, followed by a colon, and then the minutes represented as a string. And then the final thing to note is that we will not be looking at a 24-hour time period where it overlaps. So what that means is if we are at 23 hours and 51 minutes and then 0 hours and 2 minutes, that would not count as part of the same hour because that would be part of a different day. Let's look at what this problem means. In this example, I have 6 entries. I have 3 entries for person B and 3 entries for person A. If you notice that B checked in at 9 o'clock, 9:30, and 10 o'clock, this means that over these 3 entries, there were 3 times they entered the building within a 1-hour time period. 9 o'clock to 10 o'clock is, and then 9:30, that all takes place in 1 hour. But if you look at person A, they entered the building at 11 o'clock, 12 o'clock, and 13 o'clock. These entries did not take place over the course of 1 hour. So they did not emit any alerts. There was an alert sent out for person B because they entered the building 3 times within 1 hour, which means our result, the thing we return to the calling function, would just be a list containing the element B. Now, wouldn't it be really nice if there was a data structure that would map names to a list of times that they entered the building? So it would look something like this. If I knew all the times at which A entered, so say 11, 12, and 13, and if I had assorted this would make this even nicer, like it is now. And then B enters at 9, 9:30, and 10. I know this is an abbreviated list, but this makes my life a lot easier because then I can just look at every particular key in my map. If my keys are here and they map to a list of time like this, then this problem becomes a lot easier. I can just look through every element in the key section and then figure out if they set off an alert. If they did set off an alert, I'll add them to my result. Now, if you find yourself saying, wow, that'd be sweet if I had a data structure that did that, or it would be really nice if the input was like that, well, you can just make the data structure yourself and transform the input. So that's what we'll do in this problem. What we'll do is we'll take these names and then we'll map them to times. Then we'll look to see if there's an overlap, to see if there's 3 consecutive times within an hour period. And if there is, we'll add that to our result. And if there's not, then that person didn't set off an alarm and it's okay. Really, the hardest part of the problem, I think, then becomes how do you know if somebody set off an alert? So if I'm looking at B with 09, 09:30, and 10 o'clock, I know that these 3 times happen in a 1-hour period by the following. I really don't need to look at the middle time, so I'm going to cross it out. Because if these times are by sorted input, I can choose a starting position and an ending position. And if these 2 times are within 1 hour, then I know any time in between is also within an hour. What I'm going to end up doing then is if there was more times here, like 11 and 12, etc., what I'm going to do is I'm going to look at 2 particular times, say like this 9 here and this 10. I'm going to see if there's a 1-hour overlap there. If not, then I'm going to look at the next 2. I would look at 9:30 and 11, see if there's a 1-hour overlap, and then I just continue until I can no longer compare times. There's two cases to consider when you're looking at these times to know if they appeared within the same hour. The first case here is when the hours are the same. What we're really looking at is the hour value. If I have A and B down here, remember when I'm comparing 3 times to know if I have 3 within the same hour, I can ignore the middle value. If A and B have the same hour, in this case 10, then they definitely appear within the same hour. All 3 of these must be within a 1 hour time period. The second case is when the hours are different. Remember, I can ignore the middle value here, so I'm really comparing 1430 to 1520. If I can add 1 to A, remember A is going to be 1430, B is going to be 1520. If A plus 1 equals B for the hour, and A's minutes are bigger or equal to B's minutes, this is for the hour and this was for the minutes down here, then I know there's an overlap. Let's see how this looks in the code. I'm going to take more of an object-oriented approach at this problem. I'm going to make a time class to represent the times. And I'm doing this because we're currently given the time as a string, and that's really hard to read. It's really hard to parse the hours and the minutes. So what I'm going to do is create a time class to represent that. It'll have an hour and it will have a minute. The constructor will take in a string, if I can spell it. And what I'm going to do is I'm going to split the string on a colon, and I'm doing that because I know that every time is going to have the hours, then a colon, and then the minutes, like this. Now I know that the hours are going to be whatever the first item is in the tokens array, and I'm going to be converting this to an integer like that, and then same with the minute. I'm just going to convert whatever the minutes are into an integer so they're easier to use later on. I'm also going to create a compare method. I'm going to create, if I'm given another time object, I want to know if this other time is within 1 hour of the current time I have. So if the other time is within 1 hour of the current one I have, I will return true. This is pretty easy to do. If they have the same hours, then I know they are within 1 hour of each other. But if they're not, then I want to know if I add 1 to my current hour, does it equal the next hour? It's going to need to do that, and the minutes, my current minutes, are going to have to be greater than or equal to the other minutes. This example would be like if your current time is 10:30 and the next time is 11:20, 10 plus 1 right here would give you the 11, and the 30 is greater than the 20, which means that 10:30 and 11:20 are within 1 hour of each other. Now let's go to the actual code now that we have our time class to play with a little bit. I always like declaring my return variable at the top just so I don't forget, and then as soon as I do that, I like to remember to return it at the end. Now I'm going to need a data structure to map names to all the times at which that name clocked in. I'm going to call this times, and we're going to make it a new hash map. It's going to be a map from names to a list of all the times at which that name checked in. This is what the first step is. It's creating your data structure. The next step is populating the data structure, and we're going to do that just by using a for loop. Key name and key time have the same number of elements, so I could have done key time.length, but I just did key name because key name is the first parameter. It doesn't really matter though. I'm going to grab the name from key name at index I, and I'm going to grab the time from key time at that same index. I'm going to do a quick check. If I don't already have this name, if I haven't seen this name before, I want to add a new array list to that key, just an empty array list. Times dot put name, and we'll make just a new array list like this. And the reason I'm doing this is because at the end here, what I want to do is I want to get that name and then just add on to the existing array list a new time and what the current time is. If for some reason that name didn't exist, I would get a null pointer exception here. So this if statement helps prevent that from happening. Now I have my map populated with everyone's name to a list of all the times at which they appear. One subtle thing is that the times might have not been in a sorted order. What I'm going to want to do is make sure that as I'm doing the computation here, what I want to do is make sure that the list of times is sorted before I run through the computation. I'm going to iterate through everything in my map. I'm going to do the map.entry to make this a little cleaner. And we're going to do of times.entry set. I'm going to grab the list real quick. And then I want to sort it. I could make a compare function on the time class. I decided not to though, just for brevity's sake. But it would look something like this. If a.hour is less than b.hour, we return -1. That means a comes before b. Otherwise, if a's hour comes after b's hour, we know b comes first. Otherwise, they have the same hour, and I just want to compare their minutes. What this does is it converts all of the times for a particular entry in sorted order from smallest to largest. And now, if I should alert on that list, I'm going to create that method later on, but it just kind of makes sense to write it before I have it. Then I want to add that name to my result. Result.add, and then I'll get the key. Remember, the key represents the name of the person that has the alert. What I'm going to do real quick now is write that should alert, public boolean should alert. This takes a list of times. And what we do is we look at one time and then we look at 2 times ahead of it and see if they're within the same hour. And we're going to continue doing that through the whole array. So from I equals 0 to time.size, I'm actually going to call this times because it's a list of multiple elements. And I'm going to subtract 2 because I'm looking 2 ahead. So I'm going to just say time A equals times.get whatever index I'm at, and time B equals, well, just 2 ahead of me. And if, what was that method I had called? It was called with I wanted to call this within 1 hour. Within 1 hour. 1 hour. If B is within 1 hour of A, I'll just return true. If I never return true from the for loop, then I will return false. And that means there was no overlap, and that user should not be alerted. Finally, the last thing I want to do is return the list sorted. However many names I have in my result, I want to make sure that they come in alphabetical order. It's pretty easy to do. I just call collections.sort. Let's see if everything compiles okay. Yep, and it looks like we got the expected answer here. And if I submit the problem, yeah, we got a successful run here. If I look at the runtime complexity, let's do that real quick. Key name and key time have the same length. We'll call that length n. I iterate through that one time, so this is an O of n operation here. However, in the worst case scenario, I have one name only in my list with all the times associated to that one name, which means if I sort this list, I'm sorting n items, which is an n log n operation. Should alert is also an O of n operation, but that's only being called once per name inside of the array. And then finally, we're doing another potential n log n operation here. So the time complexity is O of n log n because we're doing all that sorting. Let's look at the space real quick. I'm creating a list for the result here, and I'm mapping, also creating a map and then another list here, but these are all O of n spaces. I'm not doing any squared or n log n spaces, so that means the space complexity is just O of n. And for the time, let me fix this. Big O of n for the space. If you have any questions about this problem, please let me know, or if you have any video suggestions, please let me know in the comments and I'd be happy to take a look at it. Thank you.